Alright, so we're going to take what we learned about similar figures yesterday and we're going to apply it today. So they give us two triangles. One looks like this, and one looks like this. And I try and throw you off a little bit today, because now these sides here, the longer sides, it's not as obvious because they made our triangles backwards. And that's kind of why I was telling you guys yesterday to go highlight in different colors, because it may help you be able to see things. I know it helps me because sometimes I get confused when I'm looking at stuff, but if it's the same color, it's a lot easier to decide what's what. So that way I can be like, okay, the blue line is 8, and the blue line here is 28. And then, let's see, the green line is 16 and 56. And this is from the book. It's not me just knowing or making anything up. And this is 12, and this is x. Okay? So what we're going to do is we're going to write proportions, and we're going to solve like we learned how to in like 4-3 to find out how long x is. So what we do is we take the red lines, because that has the x, so we have to use the sides that have the x, and then we can choose one other side, either the green or the blue. It does not matter, okay? But we're going to do the same thing, and we're going to put triangle 1 over triangle 2 like we did yesterday. So I'm going to use the green side, or the bottom side, because that's fairly easy to be able to remember that they go together. And then I'm going to have to use the red side because the red side has an x. Okay? So what we have to do is we have to keep our sides together. Okay, so this is going to be our, oops, let's erase that. This is going to be red. Oh my goodness, I meant to go to red and I didn't. I am just having one heck of a day. This is going to be red 1 over red 2, and we're going to set that equal to green 1 over green 2. So notice how I kept my sides together, my similar sides together, and then I started both with triangle 1 and I ended both with triangle 2. So triangle 1 is 12, and I should probably be using red for this part. So we have 12 over the red side of triangle 2 is x equals the green side of triangle 1, which is 16, over the green side of triangle 2, which is 56. Then I cross multiply, and I circle these, and I circle these, and I take my circle with my variable in it first and get 16x equals, and then you can use a calculator for that part because you're showing me you know what you're multiplying. So we take 12 times 56 and get 672, and then we have to divide both sides by 16 to get x by itself. And then again, you can use a calculator because you're showing your work and you're showing me what you're dividing by, and we get 42. Okay, so this red x is actually equal to 42. Alright, so you can use any side as long as it's a corresponding side, so like we use the green and the green, and then you have to use the corresponding sides that contain the variable. You keep your triangles together, the first shape on top, the second shape on bottom. So let's look at another one. This is a square. It's a volleyball court, is a rectangle that is similar to the shape to an Olympic-sized pool. So the first one, we have a volleyball court here, and we have 9 and 18, and then we have a pool, and this is 50, and there's a question mark here. Whenever there's a question mark, that equals a variable. So on this one, it's pretty easy to tell what our corresponding sides are because they're both rectangles. So we don't need to really highlight anything. We know we have length and width. So we have rectangle 1 over rectangle 2, right? This is 1, this is 2. So the only time that would help is if you're like, I'm going to put the red over the red, and we're going to put the green over the green. So that might actually still help some of you out, because you have to remember to write this out. The red 1 over red 2 for corresponding equals the corresponding green, and you have to keep those as green 1 over green 2. So we take red 1, 9, over red 2, which is x, equals the green line of 18 over 50. And then we circle our cross product so you know what you're multiplying. We multiply times the variable first and we get 18x, and then when we multiply 9 and 50 we get 450. Then divide by 18, and if you show me what you're dividing by, you can use a calculator and then find that when you divide 450 by 18, you get 25. So this missing length for the Olympic-sized pool is 25. Okay? So we're going to do one more of these with triangles again. You have a person here. I'm really good at drawing people, so see? You have a person there, and she is 5 feet tall, and then you have her shadow, and her shadow is 3.75 feet, and then we want to find this distance. We're like, no we don't, just kidding. We don't want to find that distance. That's a different type of math. I'm getting ahead of myself. And then we have a totem pole, which is pretty Alaskan-y, that we want to find out how tall that totem pole is, and it's like, you know, it has like a bird on it. I can't draw a person, and like, I don't know. And then it's just wooden. So it has a height, but then it has a shadow of 15.5, all right, and we go like this. So it does make a triangle. So we have our heights that I'm going to highlight in red, and we have our shadows that I'm going to highlight in blue. Okay, so remember, let's see, this is 1, and this is 2, so we're going to have triangle 1 over triangle 2, and that's going to equal our height over our height of 2, which equals our shadow of 1 over our shadow of 2. So we keep corresponding sides together. So our height of 1 is 5, and our height of 2 is h, because that's what we're looking for, equals our shadow of 1 is 3.75 over our shadow of 2 of 15.5. Okay? So then we cross multiply. So we circle our cross products, and we want the variable on the left, so we have 3.75h equals 15.5 times 5, and we get 77.5. And then we divide each side by 3.75, so you can get the variable by itself. And those cancel. And since you showed you're dividing each side by 3.75, you can use a calculator and get 20.6 repeating feet tall. So that totem pole is around 20 to 21 feet tall. That's all there is to it. Keep your first shape over your second shape, corresponding side of 1 over corresponding side of 2 equals corresponding side of 1 over corresponding side of 2. Cross multiply and divide.